All right, so today we're going to talk about rational exponents. So rational numbers, remember, are numbers that can be written as ratios, aka fractions. All right, so we're basically just looking at when you have fraction exponents. And this ties in with our unit because fraction exponents are what radicals are. Okay, so the first thing that you need to know is just how this whole thing works out. So say we have some value x and it's raised to an exponent of p over q. Okay. So the way that you kind of remember this is that, or how I sort of remember it, I guess, is that the number on top is your power and the number on the bottom is the root. Okay, so this is equivalent to, right, x to the p power with an index number of q. Or alternatively, you could also take the root of x and then raise that to the power. Okay, so it doesn't matter if you apply the exponent first and then take the root, or if you take the root and then they apply the exponent. It works out the same way no matter what. Okay, and you'll notice that there's a lovely drawing over here of a flower, okay, because this helps me remember what order they go in, because in this lovely little picture, right, the flower is on top and the roots are down at the bottom. And it helps me remember that the power goes over the roots in my rational exponent little fraction thing. Okay, so power over root, just like flowers grow over their roots. Okay, so let's take a look at some examples. So this guy right here, we want to simplify. So 16 to the 2/3 power, that is the same thing, right? Power over root. So power over root. So we want the cube root of 16 squared. Now, if possible, I always take the root first because that makes it smaller numbers and it's a little easier to deal with. But in this case, I can't take the cube root of 16. That's not a perfect number. So I'm going to say, okay, well, let me apply the 16, or the squared, excuse me, on the inside. So 16 squared is 256. And then 256, that is a perfect cube. So I can then take the cube root of 256, or I'm sorry, no, it's not a perfect cube. I'm sorry, I was thinking of a perfect fourth power. It's not a perfect cube, but I can simplify it, right? So 256 is the product of, let's see, 4 and 64, I think. Let me double check that. I can't quite remember. Yeah, 4 and 64. Okay, so I can break this into the cube root of 64 and the cube root of 4. Cube root of 64 is 4, so this simplifies to 4 times the cube root of 4. Okay, so you can see how it would be easier if you can stick with small numbers rather than jumping up to the big numbers. It just makes things a little bit easier. Okay, so this 4 here, so I'm going to convert this. So the 4 is the radicand, and then it's power over root. So fifth, and then this, I'm going to write the 2 in there, even though we don't typically write 2's, right? The 2's are understood to be there. So the square root of 4 is 2. So this is the same as 2 to the 5th, right? And 2 to the 5th power is 32. Pretty sure. I'm really doubting my basic calculations this morning. 32. Cool. All right, so we got that one. Next one, 81 to the 3/4 power. So 81 to the 3/4, so I'm going to start by converting this. So it's 81 and it's power over root. So power over root. The 4th root of 81, what times itself 4 times equals 81? Well, 3. And then 3 to the 3rd is 27. So that's my fully simplified expression. All right, 9 to the negative 1/2. So negatives, that's a negative exponent. Remember, negative exponents flip things, right? If you think back to the good old days of doing exponent rules, negative exponents tell you that you're flipping. So this is the same thing as 1 over 9 to the 1/2 power. Okay, well, 9 to the 1/2 power, that's 9, and then power over root, so 1, 2. So that's basically just the square root of 9. So this is 1/3, fully simplified. All right, this next guy, so 32 to the negative 3/2. So this is 1 over 32 to the 3/5, right? I think I said 3/2, I meant 3/5. So then I can convert that from there. So power over root, so 3 and 5. All right, the fifth root of 32 is 2. So this is 1 over 2 to the third power, which is 1/8. And that's my simplified expression. All right, and then this last guy, so 1 to the 7/8 power. So, right, if I convert this one, power over root, well, the eighth root of 1 is asking me what number times itself? 8 times equals 1. Well, obviously 1. And then when I raise 1 to the 7th power, that's still 1, right? So take a minute and think to yourself, is there ever going to be an instance where you can raise 1 to any power, right? We know whole number powers, it's going to stay being 1, okay? And we have at least one fraction exponent here where it stays equaling 1. Try to think to yourself for a minute, is there any instance where you could raise 1 to an exponent and not get 1 as an answer? Think about that, something to chew on, and figure out if you can come up with a case where it wouldn't be. Okay, so that's how rational exponents work. Remember, power over root, just like flowers go over their roots. Don't forget that negative exponents flip things.